Okay, for this problem it wants to know the number of sides of the cube that would be painted. It's only painting the exposed parts. So it has basically each term or each new picture has an extra block added on. And so these are the first three. Just trying to sketch them really quick. Okay, so this first cube has all 6 sides showing. So it would have 6 faces painted. So this is the first picture. Looking at the second picture, it would be like 6 for each cube, so I'm thinking I would add that together, but then I have to remember that there's 2 sides that are touching. So I'm going to take out for basically this part, which we're not seeing painted, but on each of the cubes, because otherwise I have too many faces. So I'm going to minus a 2. For the third guy, I would be like, okay, 6 and 6 and 6, so it's like 3 cubes, so 3 times 6. And then again, I need to take out for each of those parts where they're touching each other. So really that's going to take off 2 faces and then another 2 faces. Let's draw another picture so we can see if we can see the pattern. And again, sometimes it's nice to not simplify what you have going on. Notice I didn't even come up with answers for any of these. I just want to see what kind of pattern is happening here. And so for the fourth term, there are now 4 cubes stuck together. So I would think, okay, well, 6 plus 6 plus 6 plus 6, but wait, I need to take off that like overlapping section. So I'm going to take off 2 of those kind of sides for each one of those. So minus 2, minus 2, minus 2. And so when I do that, and again, there's plenty of other ways to do it. I did it with like kind of this subtraction. Some people might think about it a little bit differently, and that's totally fine. This is just one way to do it. But the question said to figure out what the 15th figure would kind of look like. Well, we know what it would look like. It would be 15 of these cubes stuck together. So really quickly I'm like, oh, well, that's going to be 6 15 times. But I have to think about, oh, wait, I got to take off those overlapping sections. And if you notice, there's not like an overlap on these outside parts. So I'm only taking it apart for the middles. So look for the third picture that I drew. I only took off 2. For the second one, I took off 2 2s on this one, sorry. And then for this second one, I took off 1 set of 2s. And for the fourth one, it's like, oh, I had to take that off, take that off, take that off. Again, it's on both sides of the cube that are not being painted. So we had to take off 3 of those 2s. So it's 1 less. So what I'm thinking is that would look like taking off 14 of those 2s. So if I do some math really quick for the number of faces painted, again, it's only those that are exposed, like on the outside part. 6 times 15 gets me 90, minus 14 times 2 is 28, which will give me a total of 62 faces being painted. Now if we do this in general, and again, it's really nice because I was doing this pattern to try and help me figure out what this 15th one would be. Really it's saying, okay, well, if I can think about every cube having 6 faces, I would take 6 times the number of cubes that we're talking about. So for example, when we were looking over here, this was the 4th picture, so we did 6 times 4, really, 6 times 4. And with the 15th figure, I did 6 times 15, so the nth picture I would do 6 times n, where n is the number of figures we're talking about. So this would be like the nth figure. But then I have to take off all the overlapping, and so that's 2 faces for anything that touches each other, and will be 1 less. So again, looking back at our smaller, simpler cases, we had 3 2s to take off when we were on the 4th term. When we were on the 6th term, or sorry, the 3rd term, we only had 2 to take off, and so on. And that's how I was kind of thinking about how many 2s I would take off with the 15th figure. I wrote 14 here. So then I could simplify this just a little bit. This looks pretty good. But we'll do 6n, and then we could distribute -2. That would be -2n plus 2, which simplifies to be 4n plus 2. So this is going to be the formula to find the number of faces for the nth figure. And so, like, kind of just to double check, for the 3rd figure, if I figured out the formula, it looks like that would be 4 times 3 plus 2. That's 12 plus 2, which is 14. And I'm just going to go double check my math because I didn't simplify these before. 6 plus 6 plus 6 minus 2 minus 2. So that's going to be 18 minus 2 is 16 minus 2 is 14. It worked. And I could try another case if you want to. We could try the fourth figure. Again, we're saying using this formula, 4n plus 2, we would have to do 4 times 4 for the fourth figure, plus 2, that's 16 plus 2, which is 18. And then again, just kind of double checking. This would be 6 times 4, which is 24, minus 2 minus 2 minus 2, that's really 24, minus 6, which is 18, so that works as well. So, hope that helps.